Sequential processes are predominant in today's production of sheet metal parts. At the beginning of production, the sheet material is usually coiled. The individual blanks are then produced in a pre-cutting operation. In the next step, these blanks are formed by a deep drawing process. Due to the inhomogeneous nature of the material and inherent instability of the processes, the parts are subjected to variations. These variations often lead to a shift of the operating point into a not okay area. This leads to defects on the drawn parts, which must be sorted out as scrap. Conventionally, in the event of excessive scrap rates, the operator reacts manually to this type of variation based on know-how. In this way, an attempt is made to shift the operating point back into the OK process window. Depending on the experience of the operator, this can lead to high downtimes of the production line. The resulting scrap can be reduced by the tedious and time-consuming readjustments of the process, but never completely prevented. The iLARIZ Draw.Control represents a fully automatic control system of the deep drawing process. It compensates for the material and process variations that occur during forming before the defect can manifest itself on the drawn part. By using numerically calculated sensor positions in process-relevant tool areas, changes in the process can be detected at an early stage. The closed-loop control system, patented by iLARIZ, processes the sensor signals in real time and controls the actuators in the tool. The position of the actuators is also determined numerically. In the manual tryout of the die, equipped with Draw.Control, the sensor data is recorded during the first strokes. If the part meets the quality requirements, it is defined as a reference, and the associated sensor curves are defined as a digital reference part. These sensor curves serve Draw.Control in the series process as the basis for process control. If variations occur in the process, the sensor curve deviates from the digital limit path. This indicates a scrap part. The control loop, patented by iLARIZ, automatically controls the actuators in the event of deviations from the digital limit path, so that a good part is produced despite variations. A selectively adjustable force shunt is used to locally manipulate the surface pressure between the blank holder and the blank, thus indirectly influencing the material flow during the forming process. Some examples. If at any time during the forming process it is determined that the flow in of the material is not sufficient and the part could split, the corresponding actuator generates a higher force. This reduces sheet retention and allows the material to flow more easily. On the other hand, if there is a risk of wrinkling due to the flow-in being too high, the corresponding actuator force is reduced. The sheet retention is thus increased locally, and the potential wrinkle formation is thus prevented. Thus, the use of iLARIZ Draw.Control compensates the variations in the process chain, increases the quality of the components, and reduces the scrap rate and the carbon footprint.